Ay, look.
Hello everyone who's watching out the video. Before I proceed to the main part, allow me to introduce myself first. So my name is Gianna Doños from 12th STEM Pythagoras. The main objectives of this video is to discuss the following. First, dispersion of light by a prism, and last but not the least, interference and diffraction. So without further ado, let's get started. So what is dispersion of light by a prism? It has something to do with the rainbow. You must have seen and appreciated the spectacular colors in a rainbow. So, dispersion of by a prism, when a white light strikes incident on a prism, then the light ray splits up into many colors, broadly 7 colors. This phenomenon of splitting up of light into its component colors is called as dispersion of light.
When the dispersive light rays are passing through another prism, but in the inverted position, then the dispersive light rays merges once again to form white light. The 7 colors that we see on the screen are red, orange, yellow, green, blue, indigo, and violet. To remember it easily, you can use the code ROYGP.
Hello everyone, I'm Chair Mae Bunag, and in this video, we were going to talk about interference and diffraction of waves. But before that, I'm going to show you the example of interference and diffraction of light. So on the left-hand side of your screen, there is an example of interference waves in a swimming pool. And in the right-hand side of your screen, there is an example of diffraction waves caused by a laser beam. So before we start, here are my colleague Abby to start things off by talking about interference.
Let's talk about interference. But before that, my name is Abegail Bulan. So what is the definition of interference? Interference is a phenomenon that occurs when two waves interact with one another. So suppose we have two waves that come together and two waves have overlapping crests and overlapping troughs. These types of waves are what we call in phase. And when two waves that are in phase come together, they're going to build each other up to result in a wave that has a larger amplitude, and this type of interference is what we call constructive interference. We have two waves that are coming together, and the crest of one of those waves overlaps the trough of another. These types of waves are considered to be out of phase. And when two out of phase waves come together, they're going to actually cancel one another out, and a phenomenon is what we call destructive interference.
Hello guys, I'm Jenifer Gomez. Now let's talk a little bit about diffraction. So what is diffraction? Diffraction refers to the spreading of bending of waves around edges. The fringes pattern formed by a single slit consists of alternative bright and dark fringes, and the fringes fade away from the center. So the question is, how does diffraction happen? We classically think of light as always traveling in a straight line. But when light waves pass near a barrier, they tend to bend around the barrier and become spread out. Diffraction of light occurs when a light wave passes by a corner or through an opening or slit that is physically the approximate size of, or even smaller than, the light wave's length.
The dispersion of light is the phenomenon of splitting of a beam of white light into 7 constituent colors when passed through a transparent medium. Example of dispersion of light is rainbow. Rainbow is produced by dispersion and internal reflection of light in water droplets in the atmosphere. White light from the sun enters a spherical raindrop. The different colors are refracted through different angles, reflected off the back of the drop, and then refracted again when they emerge from the drop. The white light now has been dispersed into its component colors and the different colors travel in slightly different directions.
We hope that you learned something about our video.
Don't forget to like,
Share,
and subscribe!